In this part of the presentation, I'll describe the main component of ISNOW. There are two main operations that the ISNOW connector performs on the blockchain. The first operation is the deployment of a smart contract. To deploy a smart contract, the connector sends a transaction to the blockchain. The transaction is assigned with a transaction hash and is completed when the receipt is issued on the blockchain. The transaction publishes a smart contract instance that is replicated across all the nodes. The second operation is to invoke a method on a published smart contract to write on the blockchain. Also in this case, a transaction is sent and executed across all the nodes, changing the status of the blockchain. The third operation is the invocation of a method to read some information from the blockchain. In this case, no transaction is required and the request is directly fulfilled through a call by the endpoint node to which the connector connects. This is the internal architecture of the ISNOW connector. On one side, you have the Ethereum blockchain, and on the other side, you have the ServiceNow instance. The Ethereum blockchain is made by nodes represented by an Ethereum client, for example, Geth. On the other side, the connector is made by two ServiceNow scoped applications. The first application is Spoke, made by flows and APIs that talk the same language of the blockchain node JSON RPC. Each spoke uses a data model within the ServiceNow instance to persist the required information like smart contract addresses, methods, and transactions. The second scoped application is the signer, its sign, that is required by the spoke to digitally sign transactions before sending them to the blockchain. The signer uses two tables called keys and accounts to handle the public-private keys required for the blockchain interaction and their association to ServiceNow users. On top of the ISNOW connector, low-code developer can build ServiceNow dApps, short for decentralized applications. As an example application, we will see how to deploy and use a scoped app called NowToken based on the connector. Let's build a representation of the connector's data model, including the each sign table and referenced global objects. Let's start from the smart contract object that contains the bytecode and the interface called the ABI, short for Application Binary Interface. A smart contract deployed on a blockchain network, like the mainnet, a testnet, or a private network, produces a smart contract instance which contains multiple methods. Networks contain endpoints or blockchain nodes to which the instance can connect. In our demo, we will use endpoints provided by the blockchain infrastructure provider Infura that requires a secret modeled as an integration app credential. The right methods produce a transaction that is logged in the transaction table for audit purposes. The transaction is associated with a NIT-sign account that contains the key pair associated with a specific ServiceNow user in the global user table. The ISNOW connector is made by two parts, the client side and the server side. The client side allows to use all well-known Ethereum libraries like Web3 and EastJS inside any ServiceNow object. The server side is more picky as the Ethereum libraries have to be adapted to the Rhino ServiceNow JavaScript engine. This process includes code configuration, polyfilling, and top variable mangling, and it has been done in the current version only for the EastJS library. Both the client-side API and the server-side API can connect to the blockchain and deploy smart contract, write to and read from the blockchain. The ISNOW spoke use the server-side APIs to talk to the blockchain from a more abstract layer. The ServiceNow dApps that are built on top of ISNOW are also made by a client-side and a server-side. The client side contains objects like client scripts, UI action, UI scripts, and service portal and workspace widgets. The server side contains objects like UI actions again, flows, old-fashioned workflows, business rules, and more. The client side of the dApp uses the ISNOW client API to manage the user interaction. The server side of the dApps can either talk to the ISNOW server APIs directly or, in a low-code fashion, use the Spoke components to manage any kind of blockchain-related automation.